Hi everybody, I'm Estelle from Celex, and I have a question for you. Did you know that water pollution kills more than 9 million people per year? We have pesticides, oil, pharmaceuticals, and many more that affects our health, but also destroys our environment. The problem is that pollution treatment methods, they're not up to the task. On one side, industrial methods, they are very expensive, like burning, or really not sustainable. And on the other side, bio-based methods are emerging, but they remain early stage because we are not using the most performant organisms. But what if now we could bridge this gap? What if now we could bridge this gap and bring biological solutions to the next level? Well, this is the solution we're working on at Celex by finding and scaling naturally potent bacterial degraders. We have developed a novel microfluidic technology that acts as a selective screen for bacteria that goes into a robotic enclosure that together we deploy in situ in remote environments, like in the deep ocean, and can attract and capture bacteria that can degrade our pollutants of interest. We then bring them back into the lab and we grow them in large volumes. Now, we have candidate degraders for the infamous PFAS forever chemicals, but also pharmaceuticals, microplastics, and pesticides. So how does it work? Well, in industry, they produce and store large volumes of chemical byproducts into reservoirs and get rid of them periodically by disposing them through burning. So we want to bypass burning by providing a custom bacterial culture starter that will be directly implemented in these chemical reservoirs, degrade this waste down to concentrations that are then disposable through the normal wastewater stream. This will be way more cost-efficient and sustainable. There's definitely a large potential for this, with a market of more than $26 billion yearly, and is expected to increase by 82% until 2027. So last year, we have been working on building a bacterial degrader bank and have already obtained, among others, a PFAS product, and we have also acquired our first client in pharma, a scale-up partner for our PFAS products, and obtain our first 20K. This year, we're focusing on optimizing biodegradation and scaling up our cultures to be ready for our pilot with our industrial collaborators of the Wasserversorgung of Zurich, and then pave the next steps for industry-scale pilot implementation and commercialization next year. So you'll see we're the right team for this. I bring the science, Christian here in the crowd brings the engineering, and our team of advisors give us strong guidance to move forward. So let's step together towards a greener future. We aim to raise 600K by the end of the year, and you can help us today by voting for Celex. Thank you.
Thank you very much for a lovely presentation. How expensive will it be to produce these bacteria at scale and operate? Would you do this? Do you envisage this would be in the context of standard wastewater treatment, or could you even envisage that this could be relevant in sort of humanitarian settings, like dealing with pharmaceutical waste from field hospitals?
So at first, we're targeting companies that can afford to try out these new ways of biodegradation and sustainable waste disposal. So that's why we're targeting pharmaceutical companies and also the public sector. And it would be easier to, to isolate the system so that we can also have a more monitored environment. But in the future, I really want to be able, for example, to derive enzymes from these consortia of bacteria to be able to directly use them in situ, because it will be way more easy to do so like this.
Okay, so it'll be lower technology requiring in situ, basically. You could just take the enzymes and dump them into your system. And then just a follow-up question about the breakdown. So do you know what, sometimes if you break things down, you create a new problem. So what do you know about the pathways being used and what the end products are that are coming out of your degrading bacteria?
So this is something we're looking at now with mass spectrometry. So we are assessing biodegradation rates and efficiency through mass spectrometry measurements, and we're also looking at the byproducts, not to degrade something in something even more toxic, basically.
Yeah, hi, thanks a lot. Few questions from my side. The first one, probably you have it on the slide too, like your USP. I'm quite curious about what's your USP compared to other competitors that you have.
Mm-hmm. So first of all, would be most important is cost efficiency. So we want to be the most competitive with our sustainability aspect. That comes, I think, quite importantly as number 2 in our USP. And then the third one would be scalability.
Who's your competitors? Or do you,
Sorry?
Who is your main competitors?
I didn't understand.
Your main competitors, who are?
Main competitors would be, there's different ones. So I would say first there are the traditional, methods, like we're not even looking at them as competitors, like burning. But otherwise, genetic engineering, obviously, and traditional biodegradation, although it's not up there yet to be at the industry scale for some of them. Otherwise, electrochemical degradation, but that wouldn't be considered biodegradation. But they all represent downsides as well that we could overtake.
I see. And when you talk about strategic partners, because you mentioned about pharmaceutical companies, how about others players, like what you mentioned, wastewater or chemical industry?
So we are entering a collaboration with the water supply of Zurich City to directly address their needs. I cannot disclose exactly what it is, but we also, our first client is a pharma company, so we will be developing something tailored to their needs directly. But this method is really opening us the doors to address any kind of problems. It can be also in the chemistry industry, and it has a lot of potential in that sense.
Okay, thank you.
Thank you.